Okay, so welcome everyone. Today we'll discuss the previous year's question and answer of NEET 2023 to previous years mostly. So we will try to clear all the concepts. We will try to clear all the concepts. Just wait a bit because I think some of you are still didn't join. So that's why I will just start at 10:05. Okay, 10:05 I will start. Just wait a bit. Okay, so I think most of you have already joined, so just wait a bit. 2 or 3 minutes, just wait. I will start. Okay, so let's start. So in this class actually we will mostly go through the different kind of previous year's questions which actually we have received in different NEET exams from 2023 to previous years. Okay, and so far actually we didn't complete the alcohol and phenol parts, but mostly the maximum part of alcohols and phenols we have already covered. So that's why actually I am today I am just taking this PYQ session. But after completing all of the topics in alcohols and phenols, again we will try to take this kind of question answer class. Okay, so just before starting this session, I want to just recapture what are these alcohols and phenols, or what are the basic difference between these alcohols and phenols. See, this alcohol is just, we can write ROH, where R is mostly the alkyl group, right? And these phenols, in these phenols it is mostly this phenyl ring, right? And these phenyl ring may be actually substituted or not also. If it is substituted, then in that case actually we will consider these as a phenyl part also, but in that case it may be the acidity difference can be different, right? Because when in this phenol structure any R group will be present, and if that R group will be electron withdrawing or if the R group will be electron donating, based on that this acidity of phenol will be different. If it will be electron donating group, whatever we have learned in the previous class, that if R is electron donating group, or we can say that EDW, that is electron donating group, EDG, then actually the acidity will decrease, right? Then the acidity will decrease. Why? Because the R group actually push the electron density towards the OH group, and in that case actually the bond polarity of OH will be reduced a bit, and that's why actually the acidity will be reduced. Whereas if the R will be electron withdrawing group, that is EWG, if it is electron withdrawing group, then the acidity of this phenol will be increased. Why? Because if it is electron withdrawing group, then the OH bond, then the polarity of the OH bond will be enhanced or increased, because the OR group actually pulling the electron density from OH group, right? So that's why the polarity difference between these O and H will be increased and the acidity will be increased. So that's the basic difference between an alcohol and phenol. Because in case of alcohol, the R group is mostly actually alkyl group, and that's why actually it is having the plus I effect. And if the R is having the plus I effect, then mostly the polarity difference between these oxygen and hydrogen will be less, and that's why alcohols are always less acidic than phenol, or in other words you can say that phenols are always more acidic than alcohols. And the order actually we have already learned in our last class. So this concept portion actually we will cover if the time permits in the later part of this class. but mostly actually in this class we will go through different kind of previous years questions, and I am confident that most of you will solving the questions, you will just put the answer in the chat box. Actually I will go through that, and the most important part in this every question, actually I will try to teach you how fast actually you can solve these questions. I will not show you different kind of tricks. Actually I will try to clear the different kind of concepts actually you have to build up, and through that concept actually you can crack these kind of questions within almost 15 to 20 seconds. In every questions actually within 15 to 20 seconds you can solve, and that the main part actually I will cover, that how you can solve these questions as early or as fast as possible. So try to solve these questions and put this answer in the chat box. After going through this I will solve, and again I will try to clear the concept, and after that actually I will try to tell you how fast actually you can do that. Okay, so just now you solve this question and try to put the answer in the chat box. I will go through that and give the answer as early as possible. See that NEET is a game of concept, and both concept and timing, right? Not only concept you need, actually you have to do this question within 1 minute, and I will try to teach you that how you can solve this question within 15 to 20 seconds. Okay, I got one answer, that is option 2. Someone is giving this option 2. Okay, some other answers I need. Whoever is watching, the other answers I need now. The other answers I need. Okay, someone is telling option 2 actually. The other answers I need now. Okay, now I will go through the concept section. Okay, so whenever there will be this azo compound N2 plus Cl minus is the very much easy, or is the easiest part whatever you have learned you are in our board class or normal class, that if you are just putting this Cu2Br2 in presence of HBr, so it will be first converted into bromobenzene given as H2O. So it can react to this hydrogen, or it can attack to this hydrogen, and then this OH bond will be broken. So the ultimate product or the final product would be benzene in this case. So the correct option will be 1. Now I will come to the most important part in this section, that is how you can do this question within 15 seconds or 20 seconds. See, if this kind of question is given to you, then you just first try to look at the reagent, that whenever you Cu2Br2 in presence of HBr is given, then you have to think that it will be completely converted into bromobenzene, and in presence of magnesium and dry ether, again it will be directly converted into a Grignard reagent, and when it is converted into a Grignard reagent, then that attached group with this MgBr will actually act as nucleophile, and the R group is now phenyl ring, right? So now the phenyl ring will act as nucleophile. So it will, if it is acting as nucleophile, then some electron CH3 CH CH3, then CH connected with OH, and one CH3 is already there, and it is actually reacted in presence of HBr and dilute H2SO4. The reagent is actually missing in this part, and that's why actually I have written this now. So it is actually reacted in presence of HBr and dilute H2SO4. So now what will be the product, and you have to think that how this kind of product is being formed. So what would be the product and what is the concept behind that? So try to solve this now. What should be the product and how the product you are getting, in this case what should be the product and how you are getting, because if the concept will be not clear, then these kind of questions cannot be attempted. Your concept should be completely clear. This is reacted in presence of HBr and dilute H2SO4. Then what should be the product and how you are getting? How you are getting, you cannot comment in the chat section, but the answer you can give. So what should be the product now? Try to attempt this and give the answer in the chat section. I want to know the answer. See that in presence of HBr and dilute H2SO4, I am giving you the hints. In presence of HBr and dilute H2SO4, okay, I am getting the answer as 4. Okay, I am getting the answer as 4. Two of the students have already answered. I will go through this with the concept also, but actually the correct option is 4. Actually, the students who have already answered, those are correct actually. But how you are getting, that's why actually I will go through the concept now. Correct. Actually, I have received so many answers, and all of you are correct actually. See that this OH2 plus will be removed because it is a very good leaving group now. OH cannot be removed. So to remove the OH, it has to be converted first to a better leaving group. That's why actually we are using this dilute H2SO4. In presence of dilute H2SO4, when it will be converted into H2O plus, it will be removed first and then it is converted into CH3, CH, CH3 and then CH plus CH3. Now most of the students will think about these Br minus. Now the electrophile which is left will attack into this carbocation, but it is actually wrong. That's why some questions are different in these competitive exams, right? Because competitive exams are a bit different than the board exam. In board exam you will get 1 degree, but still you have to think that if there is any kind of possibility that this 2 degree carbocation can be converted into 3 degree or not. So now that's why actually this question makes the difference. In this case, if you look at this hydrogen, this hydrogen actually will shift into this carbocation. This actually we are telling that hydride shift. These we are actually telling as hydride shift. After this hydride shift, actually you are getting a comparatively more stable carbocation. Why? Because now it is converted into a 3 degree carbocation. So when you are getting this 3 degree carbocation, now you are getting the chance that is the Br minus which is left as nucleophile. It can now attack at this position, and that's why actually we are getting the fourth product. And all the students who have actually answered in this chat section, if you can figure out these 4 parts, the organic chemistry will be easy to you. So now we are moving into the third question. So this is now the third question, whatever actually we have received in 2020 NEET exam. There are 2 statements, and among these 2 statements actually try to give the answer in the chat box. After that actually I will clear the concept, that conceptually actually how we will attempt this question. Okay, I have received one answer, that is option 1. I need other answers from some of the students. This is the third question. Just try to answer as early as possible or as fast as possible so that I can go through the concept now. Just go through the statement 1 first. Whatever is written that the acidic strength of mono-substituted nitrophenol is higher than phenol. Now try to figure out what is mono-substituted nitrophenol, because there will be OH and there will be one nitro group. Now mono-substituted difference between this oxygen and hydrogen will be increased and the acidity will be increased. So that's why the statement 1 is completely correct. It is completely correct because 3 compound. One is orthonitrophenol, then metanitrophenol, and then paranitrophenol. So the position is actually not being involved in the resonance with the OH group, right? So that's why actually it will be comparatively less acidic than the ortho or paranitrophenol. because in case of resonance to the NO2 group, if only this nitro group is present in ortho and para position, but nitro group present in the meta position cannot be involved in this kind of resonance. And this is the basic organic chemistry actually, which we have already covered in the class 11 part. In this case actually these lone pair of oxygen will be involved in the resonance, and that's why actually the acidity of this OH group will be increased. But when actually this NO2 group is present or is connected to the meta position, this nitro group in ortho, meta and para, the acidity will be different, because the minus I effect along with this minus M effect will react and therefore will act actually, and therefore the acidity sequence will be different. So that's why the statement 2 is actually maybe a problem into the network from my side also. It is not from your side actually, it may be from my side too. There is a bit problem from my side, so a bit apology for that. It may be a bit problematic, but I will try to figure out in the next class actually. Now I am staying section also. If you are having or missing having problem or missing something, only in that case you can have that replay video too. Okay, now I am moving to the fourth question. I think now it will be a bit clear, because now the signal strength it is showing as a well, now I am giving you the fourth question. This is again statement based question. There are two statements. That is, statement 1 is like Lucas test, and statement 2 is a bit different. Okay, someone has answered as option 4 should be correct, but I will check this and I will go through the conceptual part. But I need other answers too. If you are able to watch this video, if you are not able, then it is a big apology from my side, because there is a huge network problem from my side only. I have already received one answer, that is option 4 is correct. Someone is telling. I didn't get the other answers because maybe due to the some kind of side only. Okay, now I will go through. Actually you will get the turbidity very much faster than the last two cases. So this is the first thing. That is the first statement, which is actually completely correct, because by Lucas test actually you can differentiate out between primary, secondary and tertiary alcohols. Now coming to the statement 2 or the second statement. In second statement it is written as primary alcohols are most reactive, which is actually completely wrong. Why this is completely wrong? Because the answer is hidden in the Lucas test mechanism. In the Lucas test mechanism actually we have already learned this, that this state goes through the SN1 pathway. This test goes through the SN1 pathway, and if this is going through the SN1 pathway, only in that case the tertiary carbocation will be the most stable carbocation in all these three cases, not the primary one nor the secondary one. And if the tertiary carbocation will be the most stable, then only these tertiary alcohols will give this test so fast and the turbidity will get within 5 minutes. But in case of secondary alcohol, you will get the turbidity and the time you will definitely get the turbidity, but the time will take more than that the case of tertiary alcohols. And in case of primary alcohols, it will take a huge time, or mostly you will not get the turbidity. That we cannot say actually, but definitely in case of primary alcohols the time will be very much longer than the secondary or tertiary alcohols. The tertiary alcohols give the turbidity so fast because it is actually going through the SN1 pathway, and the 3-degree carbocation will be the most stable one. So that's why statement 1 is correct, but statement 2 is incorrect, and option 4 4 will be the correct. The student who has already answered in the chat section, she was actually correct because she gave the option 4. So that's why she was correct, and that's why actually look into this. Without clearing the concept or without clearing the mechanistic part, actually you cannot attempt this kind of questions, because by only memorizing the Lucas test or by only memorizing the reactant and product side, you cannot complete this kind of questions. The question is hidden in the mechanistic part of Lucas test. As the Lucas test is going through the SN1 pathway, only due to that the tertiary carbocation which is formed from the tertiary alcohols will react so faster, whereas the primary alcohol which is actually give the 1 degree carbocation actually will be the least reactive or will take the longest time to give the turbidity. Okay, so that's why statement 1 is correct, or statement 1 is correct and statement 2 is incorrect, and that's why option 4 will be the correct option. Now move to the question 5. Try to figure this out. Maximum, you can see that whatever we have learned in our last few classes, maximum questions are based on that kind of concepts. Not a single question till now we have attempted which is actually not in that conceptual part. All these questions actually we have already covered in our last few sessions in our regular classes actually. Okay, now try to figure this out. Which option should be the correct option, and how you can just means what would be the conceptual part behind this, because I have given the acetone as a reactant, then the reagent is C2H5 MgBr in presence of dry ether, that is the Grignard reagent, C2H5 MgBr in presence of dry ether, and finally it is hydrolysis, that is H2O in presence of H plus. H2O in presence of H plus. This is the hydrolysis part. So what should be the product and what will be the conceptual part? What should be the product and what will be the conceptual part? Need the answer in the chat box. Okay, someone is telling that the option 3 will be correct. I will definitely check, but before that actually I need a bit more answers from different kind of students, if it is possible, obviously. Someone has answered already the option 3, but definitely we will clear the concept. We will do this conceptually too. See that this kind of question is actually very much easy, and we have already covered this in our regular sessions. Okay, just wait a bit for 2 to 3 minutes. I will try to figure out the net. If it is possible, I will try to change this connection. Okay, now check whether you are getting this live streaming or not. Just check now if it is a bit more stable or not. Okay, are you able to now see this class actually? Are you now able to see this page? Means this fifth question is there. Are you all able to see this question actually? I am just trying to figure out the internet connectivity. Just comment in the chat box whether you are able to see this question or not. कोई भी एक बच्चा एक बार इसमें चैट सेक्शन में बोल दो अगर ये वीडियो दिख. ओके फाइन आई हैव ऑलरेडी गॉट दिस. ओके फाइन. नाउ ट्राई टू फिगर आउट द क्वेश्चन. क्लास कब से स्टार्ट होता है? क्लास बाबा 10 o'clock से स्टार्ट हुआ. ऑलरेडी मैं यूट्यूब में दे भी दिया था, इवन सोशल मीडिया में भी दे दिया था. क्लास 10 o'clock से स्टार्ट हुआ है. ओके, नाउ मूविंग कमिंग टू दिस पार्ट. दिस if you are having this acetone means this CH3 COCH3, right? Now what is the reagent now? C2H5 MgBr, right? C2H5 MgBr. So C2H5 MgBr means it is a Grignard reagent, and we have already covered in our regular class that when you will get this Grignard reagent, then this R group will actually react as the nucleophile. So it will act as nucleophile and attack at this carbon bonded to the oxygen, and this carbon oxygen bond will be broken and this O will be converted into O minus. So this is the first step. So this CH3 then O minus, or you can say this OMgBr, and at this position you will get another CH3 and C2H5 after this nucleophilic attack of this Grignard reagent. Now in presence of these H2O and H plus, so what will happen? Only the protonation step, right? So only the protonation step means CH3 then C, this is the OH, then CH3, and again at this carbon one CH2 CH3 is already there. Now if you want to have the nomenclature of this compound, so try to figure out if there is any kind of functional group present or not. Now in this case you are getting one functional group, that is the OH group. Now if the OH group or any kind of functional group is present, then try to number these carbon chain like these OH group will get the lowest possible carbon atoms. So we will try to number like 1, 2, 3 and 4 starting from the left side carbon. You can take this right side carbon atom or as 1 also, because in that case you will get the same nomenclature. So now in this case what the nomenclature will be, now at the 2 position one substituent is there, that is the methyl group. So it will be 2 methyl, then the straight chain carbon or the main chain carbon is having total 4 atoms or 4 carbon atoms, so it will be 2 methyl then bute. So there is no any kind of double or triple bond, so definitely it will be N, so butane, and the position of OH group is at second carbon, so it will be butane to all. Now these E and O are coming together, so that's why this E will be omitted, because if the two vowels are placed together then the first vowel will be removed. So that's why the nomenclature will be 2-methyl butane to all. So the option 3 will be the correct one. So now we are moving to the sixth question of alcohol and phenol part. And this very important question, one of the most important question. I like this question especially because I have already mentioned in our regular class what will be the nature on the nature of NaBH4, because NaBH4 most of you understand that NaBH4 is one kind of reducing agent. Most of you understand this, but it's a different kind of reducing agent. It is not like the other reducing agent. It is actually selectively take part in some kind of reactions or selectively take part on some kind of groups. So that's why actually it is having the specialty, and I have already mentioned in our regular classes. So try to figure out what should be the correct option or what should be the correct answer in this kind of question. What should be the correct answer in this question? someone is telling that option 3 is correct. We will think definitely check. Okay, yeah, I'm getting the answer actually. Someone is telling that option 3 will be correct. Definitely we will check, but we need other answers if it is possible. Okay, see that NaBH4, what kind of reagent is this? NaBH4, what kind of reagent is this? It is not that kind of difficult question. It is not. Actually, it is comparatively easier, and we have already covered in this regular session. That's why actually some of the students could answer this. It is actually not that much difficult. It is comparatively actually a easier question. It is comparatively a easier question. See that what the nature of this NaBH4? It is actually a reducing agent. It is actually a reducing agent. Okay, it is actually a reducing agent. Now most of you will think that if it is a reducing agent, then everything will be reduced, right? Everything means this double bonded oxygen should be reduced and this ester should be reduced, right? So most of you will think like that, but the speciality of NaBH4 lies in this question. The speciality, what is the speciality now? Now the NaBH4 can only reduce the acetyl chloride, and that's actually we have covered in your regular classes. It cannot actually reduce the other derivatives of carboxylic acid like the ester or the acetic anhydride. That cannot be actually reduced by the presence of NaBH4. In presence of lithium aluminium hydride, everything can be reduced, but the NaBH4 is a special reagent. It can act selectively. It can only reduce the acetyl chloride derivative of carboxylic acid. The other derivative like this ester, or you can say that the acetic anhydride, cannot be reduced in presence of NaBH4. So in presence of NaBH4, only this carbon double bonded oxygen will be reduced. The other carbon double bonded oxygen cannot be reduced, or the other carboxylic acid derivative cannot be reduced. So only this double bonded oxygen will be reduced, and that's why the third option is correct. See that if you know this mechanistic part, or if you know this conceptual part, within 5 seconds actually you can answer these questions. Only 5 seconds you need. Whenever you are looking at this reagent, that is the NaBH4 in presence of ethanol, then you should think that it is one kind of reducing agent which is actually acting selectively. Selectively means only the double bonded carbon double bonded oxygen, definitely that is the aldehyde or ketonic bond, and the carboxyl derivative, that acetyl chloride. Other carboxyl derivative like this ester or acetic anhydride cannot be reduced in presence of NaBH4. So only these aldehyde or ketone or this acetyl chloride will be reduced in presence of NaBH4. So that's why in this question the option 3 will be correct. So if you know the mechanistic part or conceptual part of NaBH4, that how it is reacting, you can answer this question. Okay, now moving forward to the 7th question now. So it is also comparatively easier. Just try to figure this out, that reaction between acetone and methyl magnesium chloride followed by hydrolysis. This is the simplest question I will tell. This is a very much simple question. It came in 2020 like in the corona batch actually. So it is one of the most easiest questions from alcohol and phenol. One of the most easiest questions. So what should be the answer now? In this question, what should be the answer now? What should be the answer? Reaction between acetone and methyl magnesium chloride followed by hydrolysis. Okay, someone is telling that option 3 should be correct. Okay, someone is telling that option 3 should be correct. I am not, till now actually I didn't confirm, but someone is telling that option 3 is correct. Definitely we'll try to do this conceptually. Okay, someone is telling his option 2 is correct. Okay, now the competition between option 2 and 3. Okay, someone is telling option 3 is correct, someone is telling option 2 is correct. Okay, fine. Now we will do this conceptually. Now try to figure out what is happening now. CH3, CO, CH3, right? This is the acetone, and you are having this methyl magnesium bromide. So methyl magnesium bromide means CH3 MgBr, right? So in this methyl magnesium bromide, like the Grignard reagent, if you are having the Grignard reagent, whatever I told, that the group which is actually added with this MgBr, that will actually react as the nucleophile. So what will be the nucleophile in this case? The CH3 group will act as nucleophile. So it will attack to this carbon, and this carbon oxygen bond will be broken. So what you will get, the CH3, then another CH3, then the third CH2 which is actually acting as nucleophile, and finally you are getting O minus, or you can say that OMGBr. Okay, so all will be the same. So now if you are having this hydrolysis mean H3O plus, in presence of this hydrolysis, what you will get, this O minus will be converted only to the OH group, right? So this will be CH3, then CH3, another CH3, and finally this OH. Now this is the product. Now if you want to look into this between this option 3 and option 2, what should be the correct option? Option 2 should be the correct. It is the tertiary butyl alcohol. It is the tertiary butyl alcohol. If a student do not know what is the tertiary butyl group, tertiary butyl group means that CH3 whole 3C. This is the tertiary butyl group. And if you don't know what is the isobutyl group, you should learn this basic organic chemistry, because in the basic organic chemistry actually you should understand what is the iso group, what is the tertiary group, what is the neo group, like this. Okay, so thank you very much. Someone has answered that you have already understood, so thank you very much for that. So in this option 2 will be correct. See that you have to know the conceptual part. Without the conceptual part, you cannot answer this organic chemistry question. The physical chemistry question you can answer, because there you will only get the mathematical part. But here actually you have to get the conceptual part. Without the conceptual part, organic chemistry cannot be cracked. Not a single question actually you can crack in organic chemistry without concept. So here the option 2 will be correct. Now moving to the 8th question. It is also came into this 2020. This is the COVID batch. So mostly in the COVID batch, whatever the question you will get now, mostly that will be easier than the other years questions. And this is actually very good. This question is very good actually. And actually I have already covered this in our regular classes. Mostly the regular students who have already attempted our regular classes, those should answer. Okay, someone is telling this option 3. No dear, option 3, how you can tell this option 3 will be correct? How you can tell this option 3 will be correct? See this, in case of option 3, the CH3 group is having plus I effect. The CH3 group is having plus I effect. If it is having plus I effect, so it will push the electron density towards the OH group. It will push the electron density towards the OH group. So that's why the polarity difference between oxygen and hydrogen will be less, and the acidity will be less. So that's why you should think what should be the electron withdrawing group attached to it. So now in all these 4 options, only one option one electron withdrawing group is present, that is the NO2 group. This is the electron withdrawing group, and in case of or in presence of electron withdrawing group, it will pull the electron density from OH. So it will pull. See that if this is the OH bond and someone is pulling this OH bond, then this OH bond will be easily broken, because the polarity difference is now higher, and that's why actually it will act as a better acid, or the acidity will be increased. But for example, if you are just pushing the electron density towards oxygen, then how the OH bond will be polar? In this case actually this hydrogen cannot be released easily, and the acidity will actually be decreased. So the acidity will be increased only in case of electron withdrawing group. So that's why the option 4 is correct. And see that if you know the concept, this question you can answer within 5 seconds. You don't need to wait for 1 minute actually, because you are having 180 questions in 180 minutes in NEET, but you don't have to wait for 1 minute. Within 5 seconds actually you can answer if you know the concept. See, only in case of electron withdrawing group the acidity will be increased. So that's why option 4 will be correct, because the other groups like OCH3, C2H5 and CH3 all are having either plus I effect or plus R effect. Even this OCH3 is having plus R effect. This is the resonance effect. Means that the lone pair of oxygen can involve in the resonance part with this phenyl ring. So that's why in all these 1, 2 and 3 cases the acidity will actually be decreased. Only in the option 4 the acidity will be increased because the electron withdrawing group is present there. So now moving forward to the 9th question. And this is a very good question because this already we have covered in our regular classes, because this is the one kind of hydration question, and we have already learned there are 3 processes of hydration. One is normal in presence of H2SO4, or you can say that H2O plus. Second one was this, that is the hydroboration oxidation, and third one was oxymercuration and demercuration. And I have already told you that how you can do or how you can crack these kind of questions, because here only one rule you have to remember, whether it will be Markovnikov addition or whether it will be anti-Markovnikov addition. Only you will have to differentiate this out. There are 3 total hydration reactions. One is normal hydration reaction, another one is this hydroboration oxidation, and another one is oxymercuration demercuration. So in between these 3 reactions you have to just consider which one is Markovnikov addition and which one is anti-Markovnikov addition, and based on that you can do this question, or you can solve this question. And you can also solve this question within 5 seconds actually, if you know what is the mechanistic part, or you know that what would be the Markovnikov or anti-Markovnikov rule is applied here. So this is the hydroboration followed by oxidation. So in case of hydroboration oxidation, is it Markovnikov or anti-Markovnikov? Is it Markovnikov or anti-Markovnikov? Just try to figure this out. Is it Markovnikov or anti-Markovnikov? Yeah, you are right. Everyone is right. Because in hydroboration oxidation, what is happening? This hydrogen and OH group, in this double bond hydrogen and OH group will be added, and this is Markovnikov or anti-Markovnikov. This is anti-Markovnikov. Very good. This thing actually you have to clear in this NEET class, because in the NEET class you have to clear the concept, otherwise you cannot do. This is the anti-Markovnikov, and if this is anti-Markovnikov, then this OH will move here and this hydrogen will move here. Now you are getting this answer, that is option 4 is correct. Now you can do this question within 5 seconds, right? Within 5 seconds you can crack this question. You don't need to think about it for 1 minute. Within 5 seconds actually now you can crack this question. Okay, now the question 9 is already attempted. Now moving to the question 10. The compound that is most difficult to protonate is the question came in 2019. Just think about it. This kind of question actually we didn't cover in our regular classes, but actually we gave this kind of question so that actually you think conceptually. If you have that conceptual base, then you can solve this question. You need a little bit concept to crack this. Protonate means this oxygen will attack this H plus, right? Protonate means the oxygen will attack the H plus. Okay, very good. Someone has answered 4. I am not telling that option 4 is correct, but at least you have tried. That she is telling that option 4 should be the correct option. I need other options too. If someone is able to answer, then give the answer. If someone is able, then just put the answer. Someone is telling option 3. Okay, why option 3? Protonate. What is protonate? What do you mean by protonation? Protonation means oxygen bonding with hydrogen. So whoever is acting as nucleophile, that is a lone pair of oxygen which is actually attacking. And attacking to whom? It is attacking to the H plus. Right? So only in that case it will attack when the lone pair or the availability of lone pair will be higher, right? If the lone pair will be available too much on the oxygen, then in that case it will attack, right? So now moving forward to the conceptual thing. If we are having CH3OH, now this CH3 is actually having the plus I effect. So the lone pair electron density on this oxygen is actually increasing. So that's why actually it will better, or it will attack the H plus in a smoother way, right? So it will protonate fast. Now if you are having the CH3 O CH3, again they are having 2 plus I affecting methyl group, so the lone pair electron density over oxygen is again increased and it can attack to the H plus again, and the protonation will be faster. Now think about the option 4. Now in option 4 it is like the phenyl ring attached with OH. Now these lone pair of oxygen is now involved in the resonance with the benzene ring, because the benzene ring can act as minus I affecting group, or you can say that simply the lone pair of oxygen is now involved in resonance with the phenyl ring. Now if the lone pair of oxygen is involved in the phenyl ring, then it is not that much available to attack these H plus. So the protonation or the rate of protonation will be slower, because the lone pair is not available that much. If the lone pair would be available that much, or the electron density over the oxygen atom would be that much, then it can directly attack to the H plus, or the protonation rate or rate of protonation will be higher. But now as the lone pair electron density over oxygen a little bit decreased. Why it is decreased? Because it is involved in the resonance with the phenyl ring. So that's why actually it cannot attack the H plus in a faster way. So that's why the protonation will be slower. So definitely for this question the option 4 will be correct. And see, if you know the conceptual part, how much time you need, how much time max you need 15 seconds. You don't need more than 15 seconds. Why? Because whenever you will get this kind of questions, just try to figure it out in which case the lone pair electron density over oxygen atom will be more. Now in all these 4 cases, in option 1, 2 and 3, there are electron releasing group or electron donating group like CH3. Okay, so therefore the lone pair electron density over oxygen will be increased. Only in option 4 the lone pair electron density over oxygen will be decreased due to the resonance, and the protonation or rate of protonation will be hampered. So this is the 10th question. Now moving forward to the question number 11. These we have already covered in our regular class. This is the cumene, right? Formation of cumene. These we have already covered in our regular classes. So try to figure this out. This we have already covered. These you should answer within means just 5 seconds you should answer. This is very much easy, very easier. Not even a single thought actually. This we have already covered in our regular class. Within means fraction of second actually you should answer this option. What should be the correct option? What should be the correct option? Okay, someone is telling means someone, not someone actually, means most of the students are telling that option 2 should be correct. Okay, most of the students are telling that option 2 should be correct. Most of the students, yeah. Okay, yeah, the option 2 is correct. These we have already covered, na? These we have already covered in our regular classes. So whenever these kind of structure you are getting in presence of oxygen, actually you will getting these oxygen will be involved between this carbon and hydrogen bond. This we have already covered in our regular classes. See that what we have actually covered in our board classes, based on this concept actually you are now cracking these NEET questions. Even actually we didn't cover the NEET concept, right? So the alcohol and phenol NEET concept we didn't cover till now. We are just doing this previous year's question and answer based on the board concept which I have already covered in our regular classes only. Based on this concept now you are able to crack the NEET questions. So now moving to the question number 12. That was a little bit easier. That's why actually I didn't spend that much of time on this question 11. Now think about this question number 12. Think about this question number 12. Try to attempt that. These actually once actually I tried to give you the mechanistic part in this case, and if you will try to ask me about the type of questions, then I must tell you that this is one of the hardest questions in NEET from alcoholic part or phenolic part. This is one of the hardest questions. I am not telling that much hard, but one of the hardest questions compared to the rest of the questions. If you are comparing with the rest of the questions, then I will tell that this is a bit harder. Okay, someone is telling this option 3 is correct. Someone is telling is option 3 is correct. Someone is telling is option 3 is correct. Okay, in every, yeah, option 3. Okay, and I must admire that this student, whoever is answering, actually she is pretty much correct, and option 3 is actually the right answer. No, option 2 is not correct. Option 3 will be correct. I will give you the mechanistic part also, because in the regular class, or in that in our regular class, actually we didn't show you the mechanism, because the mechanistic part you don't need in the regular board classes. So that's why actually show you the I show the mechanistic part in this class. But do you know what is the keyword? What is the keyword, or you can say that what is the command word in this particular question? Because in this question you have to estimate what will be the structure of P, what will be the structure of Q, what will be the structure of R. But do you know what is the keyword of this question? The keyword is actually P. The keyword is actually P, because most of the students will not get the structure of P, because they will think about this is like the Friedel-Crafts alkylation, so they will go through this kind of structure, that is CH2 CH2 CH3. But only in our regular class students might have cracked this pattern, because they either told this option 3 will be correct or option 2. So what is happening here? See that this is the benzene ring. So when these CH3, CH2, CH2, Cl is attacking with the AlCl3, this lone pair of chlorine atoms will attack to this aluminium. So based on that, actually it will be CH3, CH2, Cl, and then AlCl3, and it will be actually minus charged, and it is plus charged. So that's then actually this bond will be broken, and it will be formed into CH3, CH2, CH2 plus. Now you can ask me one question, that why these primary carbocation will be formed? This shouldn't be formed, right? Because this is a primary carbocation and it is a bit less stable. But that's actually we have covered already in our regular class. It is forming because there this hydride shift we can get, and because of the hydride shift, actually it will be converted into a stable 2-degree carbocation, and these we have already covered in our regular class. This is the 2-degree carbocation. Now this phenyl ring can attack these 2-degree carbocation, and if it is attacking to the 2-degree carbocation, what you will get this structure CH and then 2CH3. And if you are getting this structure, now the next step will be very much easier, because based on this oxygen, what you will get, this oxygen will take part into this reaction, and it will be engaged in between this carbon and hydrogen bond, so it is very much easier to understand that where the oxygen will be placed in between that carbon and oxygen bond. Now the main part is that in case of hydrolysis, what will happen? Now when you will put H plus into that, what will happen? You will get 1 minute. 1 minute means actually I will move this structure to the left hand side, otherwise it will be very difficult to answer. Okay. So now in presence of actually H2O plus, what will happen? One oxygen will be protonated. Which oxygen will be protonated? The oxygen which is actually at the right hand side. So this oxygen will now be protonated. So if it is protonated, then there will be a bond shift. Now this bond is actually attacking to this oxygen, and this H2O will be removed, because now this H2O plus is a better leaving group. It is one of the best leaving group, because it is forming only neutral H2O. Now when it is forming, then the rest of the product, just try to get the rest of the product. The rest of the product means this OC, then CH3, CH3, and this carbon is getting positively charged. It is getting the positive charge. Now if it is getting the positive charge in presence of H2O, what will happen? In presence of H2O, this carbon will get this OH, and with this 2CH3, right? Now if this is being converted into OH, this OH can this OH bond can be broken and it can form the carbon double bond oxygen, and these carbon oxygen bond can again break to give this phenol and acetone. Just try to evaluate the structure. So in our regular class actually I didn't show you the mechanism, because in the board classes you don't need this kind of mechanism. You will never get this kind of question in board exams, but in the NEET exam actually the concept should be clear as much as possible. So that's why actually here I try to show the mechanistic part. In presence of these propyl group, actually these propyl group will not be directly attached with the phenyl ring, because it is a 1 degree carbocation, but it after the hydride shift actually it will be converted into the 2 degree carbocation. When it will be converted into 2 degree carbocation, now the phenyl ring can attack, and then this kind of structure will be formed. When it will attack with the oxygen, then this oxygen will be placed in between this carbon and hydrogen. Now upon hydrolysis or upon protonation, what will be happen? That's actually I have tried to show in this mechanistic part. Now in presence of H plus actually these oxygen will be protonated. Now if this oxygen will be protonated, it is converted into a beta leaving group. Now how it will act as a beta leaving group? Now these phenyl carbon bond, it will actually shift to the oxygen bond and the H2 will be removed. And if it is shifting, then carbon will get the positive charge, and in presence of H2O it will be converted into OH. Now if it is converted into OH, then the OH bond can be broken to be converted into carbon double bond oxygen, giving the ketone, and the rest part will be converted into the phenol. So the option 3 will be the correct one. So that's why actually I have told you that this is one of the most hard questions so far whatever we have received in NEET exam. So it came in 2018. Okay, now coming to the question number 13. Just try to figure out what is the keyword here. You have to consider the keyword, because in every question there is some kind of keyword or comment word through which actually you can easily answer. There is some kind of keyword or comment word actually through that actually you can answer. You don't have to look out the whole question or a whole data. You have to look out, or you have to figure out what is the keyword. Based on the keyword actually the answering of the question will be easier. Okay, someone is answering that option 1. Someone is answering as option 1. Definitely we'll move to the answer. Someone is answering option 1. Okay, I will look into the other answers also, whatever the possibility. Someone is answering option 1. Whatever the other students are thinking, just try to figure this out and put the answer in the chat box. What should be the correct answer, and how you can figure it out? What should be the keyword or what should be the comment word in that question that you should consider? What should be the keyword or comment word in this question you should consider? Because if you know the keyword, if you try to figure out the keyword, only in that case actually you can answer this very fast. Within 15 seconds actually you can answer this question. Within 15 seconds. Okay, there are two keywords. See that one keyword is B, another keyword is C. One keyword is B and another keyword is C. One keyword is B and another keyword is C. Now think about this. Why I am telling that is the keyword? Because A on treatment with sodium gives B. So B definitely contains sodium. And B and with PCl5 gives C. So C definitely contains chlorine. Now if you try to figure it out, then you can easily come to the answer that the option 3 will be correct. But I will definitely go through the conceptual part. But before that, I am trying to tell you that you don't have to go through the whole question. If you know the conceptual part, only by 15 seconds you can answer this kind of question. Suppose A on treatment with sodium, what will happen? Something like B, in case of B, so it should contain that sodium, right? It should contain that sodium. Now in presence of PCl5, it is converted into C, right? It is in presence of PCl5 means A. In presence of PCl5, the A is converted to C, so C definitely will be a chloride. It will be a chloride sample, definitely. So that's why the option 3 will be correct, definitely. But we will go through mechanistically. Now what is telling that B and C react together to give a diethyl ether. What is the diethyl ether? Diethyl ether means C2H5O C2H5. Now look at the B and C in every option. B and C in every option. Now in this option, can it attack to some other reagent to give this? No, it is not possible because oxygen is not there. So B and C cannot attack themselves, cannot be involved in a particular reaction to give this diethyl ether. Now look into this second option. Now in this case, in the second option, actually it is possible to give this particular product. It is possible to give this particular product. Now look into this third option. Look into this third option. It is also possible to give this product, that is C2H5O C2H5. But see this last option. The last option, it is also not possible. So the option 4 and option 1 is not possible. These 1 and 4 options are not possible. Now compare in between 2 and 3. Now in between 2 and 3, how you will consider whether this option 2 will be correct or 3 will be correct. See, just try to figure this out. What is the C? C upon treatment on PCl5, it is being produced, right? So definitely the C will be chloride. And what is the B? B upon treatment of A with sodium is being produced, right? So that's why B definitely will contain the sodium, right? So definitely the option 3 will be correct. So this is the conceptual part I am telling, but without getting into that whole question and the options, you can just crack this by evaluating the keyword or comment word. Here the keyword is B and C. Just try to figure out what should be the B. B should contain the sodium, and what should be the C? C should contain the chloride, right? Because it is after attacking the involving A into the reaction with PCl5, it is being converted into C. So definitely C should be a particular chloride, right? So therefore the option C should be correct without evaluating or without being involved into the conceptual part. Actually, just with the keyword or the comment word, we can crack this kind of question. Okay, now move to the question number 14. Move to the question number 14. This actually I didn't tell you in the in our class, because we didn't cover in these chloroform part. We have already covered these haloalkane and haloarine part, but in that section actually we didn't cover this chloroform part. This chloroform part definitely we will cover in our later classes, but in this class actually try to figure this out. Mostly maybe it will be a bit difficult to you, because as it is not covered in our regular classes, but still you can try it a bit. You can try a bit at least. Because in these whole questions, nobody has asked you what should be the product, what should be the condition. Only the electrophile have been asked by the examiner. Yeah, I have got the answer. I have received the answer. Yeah, I have already received the answer. I have received the answer. Okay, see, someone is telling option 3 and someone is telling is option 2. See that you have been asked what will be the electrophile. See here CHO means that CHO is not an electrophile. Definitely electrophile means what will be the electrophile generated based on this reaction. See that here whatever the mechanism, you have to look into that. So now in presence of NaOH, you will get this OH minus, right? It is the base, and this hydrogen is very much acidic. This hydrogen is very much acidic. Why this hydrogen is very much acidic? Due to this electronegative chlorine atom. As 3 electronegative chlorine atoms are attached with this carbon, so that's why the total electron density is being pulled out by these 3 chlorine atoms, making the hydrogen a very much acidic in nature. So that's why what will happen? So that's why these OH minus will attack this hydrogen, and then this CCl3 minus will be formed. So with the in presence of this NaOH, this chloroform will be converted into CCl3 minus and H2O will be released. Now when you are getting this CCl3 minus, one chlorine will be removed and it will be converted into CCl2. It will be converted into CCl2, and that is the electrophile. Actually it will be a bit difficult because I didn't cover it in our regular classes, but if you go through the mechanistic part, now you can easily convert this reagent into a particular electrophile. You just have to think what would be the nucleophile and what will attack to whom, and after that actually you can easily get what you are getting. See that if you can easily get the CCl3 minus, maybe the last step a bit difficult to you because I didn't show you in our classes, but you can easily get the CCl3 minus now based on the concept, because in case of CHCl3, this hydrogen is a bit very much acidic due to these electronegative chlorine atoms, because 3 electronegative chlorine atoms are added with that, and in presence of the base, this OH minus will attack this acidic hydrogen, leaving CCl3 minus. Now this CCl3 minus will leave one Cl minus to be converted into CCl2 radical, and it will act as the electrophile. Actually this CCl2 is named as dichlorocarbon. It is known as dichlorocarbon. Normal CH2 is known as carbene. So in this hydrogen is being replaced by chlorine atom, so that's why it is named as dichlorocarbon. So electrophile will be dichlorocarbon. Now I will tell you how this product is being formed. I am just telling you how this product is being formed by the mechanistic part now, though actually it is not the part of the question, but it may come later. So that's why I want to give you the mechanistic part, how it is being converted into aldehyde. Now if this is OH minus, in presence of NaOH, it will be converted into O minus, right? It will be converted into O minus. Now the electrophile is CCl2, that is dichlorocarbon. Now this O minus can take part into resonance, and these double bond can attack these CCl2. CCl2 means dichlorocarbon. So it will be converted into like this. This CCl2 minus, here one hydrogen will be there, and this intermediate will be formed. Okay, this intermediate will be formed. Okay, I will make this section a little bit shorter, otherwise I cannot show this. Oh, sorry. Okay, so now this intermediate we are getting. After getting this intermediate, what will happen? These negative charge over the carbon will attack this hydrogen. These carbon hydrogen bond will again participate into this resonance, and this oxygen will be double bond will be broken to change into O minus. Now it will be O minus. Here you will get this CH, now Cl2, and this, right? Now do the protonation. It is now very much easier. Now do the protonation. This is in presence of H2O plus. Now in presence of H2O plus, what will happen? You will get this OH, and here in presence of 2 chlorine, it will be substituted to 2 OH. Now in our regular class, we have already mentioned that if in a particular carbon 2 OH is there, you will just try to figure out that one H2O will be removed. One H2O will be removed. So if one H2O will be removed, you will get this product. So it is easier now. So in presence of NaOH and chloroform, this dichlorocarbon will be formed as an electrophile. Now these phenoxide ion will act as nucleophile to attack that CCl2, that is the dichlorocarbon. After attacking that, followed by protonation, it will be converted into CHO group. So that's the complete mechanistic approach. I think this is clear to you. So I am moving to the next question, that is question number 15. That is question number 15. Now moving to the question number 15. I think this is very easy. I have already covered this in our regular classes. This is very much easy. You should answer this question. Even if you are a regular class candidate, then I think you can answer this question within a fraction of second. Yeah, within a fraction of second. Very good, very good. I have already got the answer from one of my regular student actually. I need answers from other students too. Now the connection is, I think, excellent, because it is showing like that. I don't know what is the actual speed, but it is showing that excellent network connection is there. I want to know some other answers from different candidates. Okay, I am getting the answer. Okay, I am getting another one answer too. Yeah, very good, very good. Because NO2 NO2 is the electron withdrawing group, right? NO2 is electron withdrawing group. As much as NO2 will be engaged with the phenyl ring, so the electron withdrawing group, or the number of electron withdrawing groups, will be increased. So that's why all these electron withdrawing groups will pull the electron density from the phenyl ring, and the wedge bond will be more polar in nature, or the polarity difference between the oxygen and hydrogen will be higher, and that's why it will be much more acidic than the other phenol, where only one NO2 is attached, or you can say only CH3, where CH3 group is having the plus I effect. That's why the acidity will be again reduced, and it will be reduced than phenol 2. So that's why as the number of electron withdrawing group increases, like the NO2 group, the acidity of phenol will be increased. And you can answer this within fraction of time actually, within fraction of second actually. You can answer this question by looking into the option, because as you are getting the NO2 in the option, so as the number of NO2 will be increased, so that's why the polarity difference between the wedge will be increased, and you will get the option 1 as correct. Now moving to the question number 16. Now moving to the question number 16. Now the oxidation of phenol with chromic acid gives. The oxidation of phenol with chromic acid gives. Chromic acid is actually an oxidizing agent. Chromic acid is, what is the chromic acid? Behavior is, chromic acid is oxidizing agent. It is a very important part. Chromic acid is oxidizing agent. So what will happen? What will happen in presence of oxidizing agent, that is chromic acid? That is chromic acid. In presence of chromic acid, what will happen? Okay, someone is telling option 1. Someone is, okay, option 3. Someone is telling option 1. Someone is telling option 1, someone is telling option 3. Okay, no, it will not give aldehyde. How it can be converted into aldehyde? See, these wedge cannot be converted into aldehyde now, because it is already bonded to the carbon where not a single oxygen, not a single hydrogen is there. So therefore, it cannot be converted into aldehyde, right? Because this carbon is connected with other two carbons. This carbon is connected with other two carbons, so it cannot be converted into aldehyde. Aldehyde cannot. It cannot be an aldehyde. It will be a conjugated diketone. It will be a conjugated diketone. It will be a conjugated diketone. Okay, this is the answer. When phenol is actually oxidized in presence of chromic acid, it will be converted into a conjugated diketone. Actually, what is the name of this diketone? Do you know what is the name of this diketone? What is the name of this diketone? Do you know that? Do you know what is the name of this kind of conjugated diketone? You should know the name actually, because every time this other times this question is coming into the exam, then you may not get this option, that conjugated diketone. You may not get the option. The other option or the name of the compound can be given. Okay, the name of the compound is Para-benzoquinone. Okay, and this the orthobenzoquinone structure is this one. This is the orthobenzoquinone. Okay, and in this case actually we will get para-benzoquinone. When the phenol will be oxidized, it will be converted into para-benzoquinone. But in this case actually para-benzoquinone is not in the option. That's why actually it will be conjugated diketone, because it is conjugated like this. So that's why actually it will be conjugated diketone. Okay, it will be conjugated diketone, because orthobenzoquinone will not be the correct option. Okay, so question 16 is already attempted. Now go through the question number 17. Question number 17 actually we have already done in our regular classes, I think, this has been done in our haloarine part. Mostly this has been done in our haloarine part. So what will be the correct option here? What should be the correct option here? Question number 17. Question number 17. What should be the correct option? Okay, someone is telling option 2. Yeah, you are correct. Option 2 is actually correct, and actually this has been done in your haloarine classes or a haloarine PYQ session. So now here actually if you are having this NH2, this hydrogen it can take and this hydrogen you can take. But actually what will happen? As this OCH3 group is having minus I effect, so this hydrogen will be comparatively more more viable to live, right? Because as this NH2 minus will take this hydrogen, so the negative charge will be developed here and it will be stabilized due to this minus I effect of OCH3 group. These minus charge will be stabilized due to the minus I effect of this OCH3 group. Why? Because the minus charge will be stabilized, because the OCH3 group is now placed just adjacent to the negative charge, so that's why it will be stable. Otherwise the negative charge will be formed here, but then the distance from this negative charge with that minus I OCH3 group will be a bit longer, so therefore actually it will be comparatively unstable than this negative charge which is just formed adjacent to the OCH3 group, because of the minus I effect of OCH3 group, this negative charge will be comparatively more stable. Now if this is more stable, then this negative charge will take part into this double bond or resonance to remove this bromine. Now this benzyne intermediate will be formed. In this case the benzyne intermediate will be formed. Now again you have to think that where these NH2 minus will attack. Now NH2 minus can attack here or NH2 minus can attack here, but these NH2 minus will not attack to the adjacent position of OCH3 group. Why? Again the same reason, because if the NH2 minus is attacking at the meta position with respect to OCH3 group, then this NH2 will be here and the negative charge you will get at the adjacent position of OCH3 group. Again this negative charge will be more stable due to the minus I effect of OCH3 group, so that's why finally the product will be NH2 group with respect to OCH3 at meta position, and the reaction will be substitution. Why substitution? Because in presence of this bromide only NH2 group is involved, and this kind of question actually we have solved in our haloarine part. It's the same question actually we have solved, and there actually I have shown you the mechanistically why the negative charge is not being formed adjacent to the bromine or left side at the bromine or at this position. Actually I have already mentioned this, or I have already revealed this in our regular classes, that why this negative charge is not being formed at this position, because the distance from this to the minus I affecting OCH2 group will be a little bit longer. That's why it will be comparatively less stable, whereas these minus charge which is actually being formed adjacent to the OCH3 group will be highly stable due to the minus I effect of OCH3 group. So that's why it will be formed as intermediate. Then the negative charge will take part in the bonding. It will form the benzyne intermediate. After forming, this is the benzyne intermediate. After forming the benzyne intermediate, again there is possibility, or there are two possibilities of attacking the NH2 minus, that is the nucleophile. Now on the nucleophile, NH2 minus can attack at the meta position with respect to OCH3, or it can attack to the ortho position with respect to OCH3. Now if it is attacking to the meta position, then the negative charge will again be developed adjacent to the OCH3 group. Now again these negative charge will be stable due to the minus I effect of OCH3 group. So that's why we will get this product, and this is one kind of substitution reaction, because in case of bromine, the bromine is replaced by the NH2 group, or it is substituted by the NH2 group. So it is named as substitution reaction. So this is question number 17. Now coming to question number 18. In this class we will solve total 20 questions. So 3 questions remaining. After this after solving of these 20 questions, we will end this class for today. In the next class actually we will do some kind of conceptual part from this alcohol and phenols too, and after that we will again resume this PYQ or different kind of question and answer session from this alcohol, phenol and ether part. So this is now question number 18. Try to attempt that. Reaction of phenol with chloroform in presence of dilute sodium hydroxide finally introduces which one of the following functional group? This just now we have covered before the 2 or 3 questions. Mostly we have covered in presence of chloroform, NaOH, what will be formed as electrophile, that is the dichloromethane, dichlorocarbene we will get as the electrophile. Then that phenoxide ion will attack the electrophile to be converted into which group? I have already received the answer, but other students are not answering. That's why I am asking which group will be introduced. Just before 2 or 3 questions we have revealed this mechanism. Just before 1 or 2 questions mostly I have revealed this mechanism. What should be the answer? The answer will be, yeah, aldehyde. The answer will be CHO. You are correct. The answer will be CHO, that is aldehyde. I have already shown you the mechanism. Before 2 or 3 questions. This is the mechanism. See that phenol, upon action of NaOH or in presence of NaOH, it will be converted into a phenoxide ion. Then the phenoxide ion can attack as nucleophile to these dichlorocarbene. These dichlorocarbene upon protonation can be converted into the CHO group or the aldehyde group. So this is the question number 18. So see that the question number 18 can also be answered within 5 seconds, because if you know the mechanistic approach or conceptual part, you can do this question within 5 seconds too. Now coming to the question number, okay, actually I have written again the question number 18. Okay, now coming to the question number 19. This is also one type of easy questions, I think, actually, and you should answer. I think you can answer this question. I think you can answer this question. So try to figure out what should be the mechanistic part or the conceptual part. Then you can easily answer this question. Yeah, very good. I have already received the answer. Actually you are correct. The option 4 will be correct. Why? Because see that HBr is present with H2O. The reagent is HBr in presence of H2O2. In presence of H2O2 means peroxide. So peroxide means anti-Markovnikov addition. So if it will be anti-Markovnikov addition, so the product will be like CH3CH2 then CH. This CH2 will contain this bromine and these carbon will contain the hydrogen. This will be the anti-Markovnikov addition. And now in presence of this C2H5O minus Na plus, so it will act as a nucleophile. It will act as a nucleophile. Which one act as a nucleophile? That ethoxide ion. That ethoxide ion will act as nucleophile. It will not act as base, it will act as nucleophile, and it will give an SN2 reaction. So it will attack to this carbon and this bromine will be removed. So if the bromine will be removed, you will get the product like CH3, CH2, 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 O, CH2, CH3. Now if you are comparing all the products, this option 4 will be the correct option. Option 4 will be the correct option. Just look into this mechanism. It is very much easier whenever you are getting or whenever you are having this HBr. So the hydrogen and bromine, or there's that hydrohalide, right? Hydrogen and bromine. So hydrogen will be attached to one carbon and this bromine will be attached to another carbon based on the Markovnikov or anti-Markovnikov rule. So as the H2O2 or peroxide is present, it will be anti-Markovnikov addition. So hydrogen will be added to that carbon which is actually containing less number of hydrogen atoms. So hydrogen will be added to this carbon. Hydrogen will be added to this carbon and bromine will be added to this carbon because this is anti-Markovnikov addition. After this anti-Markovnikov addition, what is the second reagent? That is C2H5O minus Na plus. That is the ethoxide ion. Now ethoxide is comparatively smaller, not that much bigger. If it is tertiary butoxide, then it will act as base rather than a nucleophile. But C2H5O minus, it is a better nucleophile. Why? Because actually it is smaller in size and the reaction will be SN2 in nature. If it is SN2, then it will directly attack to the carbon attached with bromine, and then the Br minus will be removed as the leaving group because it is a good leaving group. And if it is removed, then the option 4 product will be formed. So that's why the correct option will be option 4. So coming to the last question of our session, that is question number 20. So this is the last question of our session. This is the last question of our session, that is question number 20. This portion or this concept actually I have revealed in the last class, in the last regular class. This concept I have revealed. Those who have attended in the last class or those who have already watched in the last class, he or she may answer this question. In the last class actually we have covered this portion, that when a particular acid is actually reacting with sodium hydrogen carbonate, what is happening? Okay, someone is telling that option 2 will be correct. Someone is telling that option 2 will be correct. So I am going through the mechanistic concept now. So if some acid is reacting with Na2CO3 or an acid is reacting with NaHCO3, in both these two cases this carbon dioxide will be carbon dioxide will be liberated. Only in that case, if the acid will be carboxylic acid, if the acid will be carboxylic acid or strong acid, or you can say or strong acid, but phenol is unable to do that. Why? Because phenol is actually weak acid. Phenol is actually comparatively weak acid than carboxylic acid. So if you are comparing this, then benzoic acid cannot be the option. Why? Because if the benzoic acid is containing the COOH group, that is the carboxylic acid group, definitely upon react with this sodium hydrogen carbonate, or you can say that sodium carbonate, this carbon dioxide will be liberated, and that's why it will be soluble in nature. Again, in this sulfonic acid, this is the acidic group, so that's why these cannot be the correct option. Now between these 2 and 4, see that orthonitrophenol and 2,4,6 trinitrophenol, this 2,4,6 trinitrophenol will be comparatively comparatively strong acid, will be comparatively strong acid. Why? Because of the 3 minus I affecting NO2 group, or you can say because of the 3 electron withdrawing NO2 group, these OH will be a bit more stronger to give as H plus, or you can say these 2,4,6 trinitrophenol will be comparatively a more strong acid than orthonitrophenol, because this orthonitrophenol is containing only one nitro group. So that's why if you are comparing this option 2 and 4, so option 2 will be comparatively less acidic, and if it is less acidic, then it will react with NO2CO3, but it cannot liberate CO2. So if it cannot liberate CO2, then it will be not soluble in sodium hydrogen carbonate or sodium bicarbonate. In any of these two cases, it cannot liberate CO2. Why? Because only this is the option, that is the orthonitrophenol. It is least acidic or weakest acid if you are comparing with the rest of the options, because in case of benzoic acid, it is having the COOH group, also it is highly acidic. The option 3, that is a sulfonic acid, so SO3H group, it is also very much acidic. And if you are comparing between option 2 and 4, both are phenol. So phenol is comparatively less acidic, so either option 2 will be correct or option 4 will be correct. Now look into these minus I affecting NO2 group. As the number of minus I affecting group will increase, so acidity will be increased. So between 2 and 4, this 2,4,6 trinitrophenol, that is option 4, will be a stronger acid than option 2. Now this option 2, as it is least acidic in nature, it will react with NO2CO3 or NaOH definitely, but the CO2 cannot be liberated. As the CO2 cannot be liberated, so it will not be soluble in this sodium hydrogen carbonate or sodium carbonate. So that's why this option 2 will be the correct answer. So now the session is complete. So that is the complete PYQ that we have taken in our in this class. In the next class, actually we will go through some important concept of this alcohol and phenol part 2, because based on those concepts, the next class will be different kind of question and answer. We will try to figure out conceptually. So I will ask the students who are still there in the live session, I will ask them whether they are having any kind of doubts in any kind of questions conceptually, or in different questions too. If they are having any kind of doubt, they may put their queries into the chat option. I will try to figure this out, or I will try to solve the query. If you are having any kind of questions or doubt, just put this in the chat option, or otherwise just you can put this word okay or anything else, so that I can confirm that so that I can just understand that you have understood this whole class or whole concept in this PYQ session. Just confirm whether you are having any doubts or not, and if you are not having any kind of doubt, you can just put the message as okay, so that I can understand. Okay, fine. And other candidates who are actually still there, I am just asking them, who are actually still there, I am just asking them. Okay, thank you very much. So I am just ending this session. If you are having any kind of problem, you can also call me to my number, if you know that number, because it is already given in the thumbnail also. So thank you very much. I am just ending the session. Thank you.